Okay, welcome to the special benchmarking meeting, PGO Deep Dive. We have Kunal here with us, who's going to take us through the investigation that he's done. So I'll hand it over to you, Kunal.
Hi everyone. This is Kunal from Microsoft, and from last few weeks, I was studying some performance benefit that we get about from profile guided optimization. So this is my like whatever research I did and the results that I have seen. I wanted to just present and know like what people think about it. Um, so let's start. Basically, what is PGO? PGO stands for Profile Guided Optimization, where you first compile a binary, compile an instrumented binary, and what that means is like the compiler will add patches to the flow graphs of the source code, and once you have the instrumented binary compiled, you just run through the training scenarios. Which will okay wi- you run through the training scenarios, and the instrumented binary records all that information and dumps it into some profile data files. Once your training scenarios are done, you take those profile data files, you take those instrumented binary, and then recompile the binary to get the optimized binary. What that does is like from the profile information, it knows what were the hot code path that were taken during the training scenarios were executed, and it optimizes the code for those code paths. And that's why like it is like a optimized binary compared to the normal binary. So some of the benefits that we get from PGO is like it enhance the program locality. Basically, it knows what basic blocks I jump to, and that's why it brings them closer to each other. There is also like benefit of virtual call speculation. Like you have multiple derived classes, and you have some virtual calls. From the profile information, it knows like what were the most apparent derived classes that it called into, and there like you can do some like it does some optimization. There is like function inlining, some better register allocations because it knows like what kind of assignments you were doing in while recording that scenario. Also it knows like the branch prediction, and I will talk about it a bit on the like in the next slide. And it provides a it generates optimized code for overall for the like most important regions of the program, which are like most beneficial for the training scenarios that we have performed. So for example, like take a look into like this code. Let's say you have this are blocks where you have from A to B, you just go once, and then there is a like condition where you just like go one at like in one condition, but like 100 times into block C, and the C has another condition where 90 times it goes in through the right flow, and 10 times it goes through the left flow, and then from E you get goes to F by like 90 times. Normally, if you see on the right hand side on the part A, in the normal binary, the programs will be the basic blocks will be arranged like this, like A, B, C, D, E, F, just like whatever it has seen. But if we use profile guided optimization, it knows that it has taken path C, E, F like more than it did from C, D, F. So what it did is it moved block E closer to C, so your jumps are like not far. It's like near jumps, um, and the infrequent execution like those blocks are moved down. So for example, block D has been moved down, and that's like one example of what information what how it benefits from the information it records. And there are like many other information like what I called in the previous slide, a lot of information gathering, and using that it produces the optimized binary. So some of the case studies like we have known like ASP.NET Core, in the recently they published a blog and they used this PGO binary. They saw like 5 to 10% optimization in improvements in the startup of the like music app, for example. Chromium does that. They published a blog recently like in October about like they will be making Chromium like build with PGO binaries. Mozilla had that for a while. Python does that. So there are like this PGO technology is a proven technology, basically, that many big projects want to use that, and they use that to get the benefits or improvements. And yeah, and I have like added some link about the PGO down below. So with that, I wanted to experiment how beneficial it is for Node. Um, and basically what I did was I choose a training set and basically I use Acme Air benchmark, a Tech Empower benchmark, the core benchmarks that Node has, and the top 10 Node modules that most of the modules are dependent on. And this list I have taken from, like, I have included a link from where I have taken this list, and the right hand side sees like all those 10 modules that I use. And basically I just ran unit tests of those 10 modules, and obviously npm install to install those 10 modules. So this was my training set, and what I did is like I trained this binary, produced a PGO binary using this training set, and then measured the performance improvement that I see on Acme Air, Tech Empower, and core benchmarks. So this is the result that I saw. So this is based on the node of like January, as of January 3rd. So in Acme Air, I saw like 5% improvement. Tech Empower, I saw 7% improvement. And there are like a lot of improvements in the core benchmark. I have like the entire like the detailed of individual benchmark improvement is listed here in this in my just GitHub. But like just to summarize, like buffer has like 25 through 50% improvement. Query string has up to 30%. The crypto util timers, they have up to 20% improvement, and HTTP had like 15% improvement. And that's again like without hand coding any of the thing. Like it's just like running the training scenarios and recompiling the node binary with that training scenario. I didn't have to do anything else, and I could see this benchmark, this improvements in this all this benchmark.
Were there any that went down?
No, like that's what, like, so in the at least like, so basically like whatever training scenario I used, I measured performance on those benchmark. So it's very likely that I haven't seen any regression on those benchmarks, but it is like definitely possible that some other scenarios might have regressed. And that's the point I will talk about in the challenges section.
Sure, okay.
Yeah, but yeah, like just to like whatever training scenarios you are doing, like at least like those are getting improvements. The other exercise that I did was like I just use Acme and Tech Empower as a training set, and there like I saw improvement in Tech Empower for like 14% versus previously I just saw for 7%. So it depends on what training set you have used, basically. So the challenges in this PGO thing is you need to choose the right training set, which means that you want to make sure that you have like improved the common scenarios, but you haven't regressed much the uncommon scenarios. Like there's definitely a trade-off, but we want to make sure that the most common scenarios are benefited by this PGO binaries. The other challenge is you need to have a robust automation for executing this training scenario, because now we are talking like if we are want to do this in CI, basically what we are saying is like you build node, you execute this training scenario, you rebuild node, and that's where you get the PGO binary. So you want to make sure that all those training scenarios, like there are no failures, and it has like recovery if there are any failures, and make sure that the profile data files are not missed by when we execute the training set. For example, like when I was testing this with Visual Studio, like I saw the some of the profile data files were not getting generated, and I had to like write some different script to make sure that every every second the profile data files are getting generated. So that's like we need to make sure, like that's one challenge. The profile data files are not shareable across like architecture or platform or builds. So you can't have like just one profile data file and then just rebuild the optimized binary on different architectures or platform. Like you have to do this exercise like for every flavor slash every platform.
But that was one question I had. Is like, but could you do the training once and then reuse those files across builds, or is you have to
No,
do it for every build?
I mean, we have to rebuild. I haven't tried for different architecture. I can give it a try, but as far as I know and what I read on like internet, you need to make sure that the PGC files are basically like create generated like separately. Part of the reason is like there are multiple files. At least for Windows, there are like multiple files that are produced once you build instrumented binary, and that file is actually used while you actually build the optimized binary. So basically, like the first build has to happen on the same matrix as the second build. So yeah, so and that brings to the last challenge, which is like the build time will increase for this. Like it will be like twice plus time spent in running the training set. Um, So again, the summary basically just wanted to get is there is a significant performance win in most of the benchmark, like at least what I experienced. And the optimization is done by the compiler, like there is no hand coding. It's just like out of the box. And there are tools available for doing the PGO. Like I tried on Windows, and like folks from Intel tried this thing on Ubuntu, and this like he also shared the instructions. So I believe like it is available for every platform. But the downside is like yeah, you have the increased build time. You need to find the right training set, and there should be like there has to be some way to evaluate the side effect of on other scenarios. So just wanted to get thoughts of like community, like how they think we can solve this side effects, this downsides, and see what they think on getting this PGO binaries.
Yeah, I mean, I guess it's going to be really tough to figure out whether you've got it right or not, right?
Yeah, so like what? Yeah, exactly. But like today we don't know like I mean today we don't know how the performance of node is in other like outside benchmark.
Right.
So yeah, at least like and I think that's why the benchmarks are to basically judge the performance on node on the real world.
Right. I'd be curious, like what would be interesting for me anyway would be is if we say we trained it on Acme Air
Mm-hmm.
only, do we
Mm-hmm.
actually see degradations in the micro benchmarks? Or if we trained it on the micro benchmarks, do we see degradations in Acme Air?
Okay, I can try that exercise.
Because that would say, like, if we can't find a case where it makes other things worse,
Uh-huh.
then it makes you a little bit less worried about that, right?
Yes.
But if we run those two simple cases and one is significantly worse than the other, then it says, okay, well, yeah, we've got to make sure we have a full set.
Right. Yeah, and I already have the binary for that is trained just for Tech Empower and ECMAIR, so I can use that to test out the core bench like micro benchmark.
Right. Yeah. Okay. So yeah, I think that would be kind of like an interesting data point. The
Okay.
other one is even just on the build front,
Mm-hmm.
there'd be a significant challenge there, I think.
Yeah.
Because today I don't think people are it's going to fly to double the build time
Right.
for regression testing.
Uh-huh.
At the same time, that's all the testing we have. Like when we go to do a release,
Mm-hmm.
I guess we launch a build now. We'd have to see in the releasers if just in the release run we could be willing to double the time or not.
Okay. I see. Oh, so you're saying like just while releasing generate the optimized binary instead of like CI.
Yeah, except that yeah, so it's not really the way that yeah, exactly, right? Like the thing is the current CI jobs for releases don't actually run any tests.
Okay.
But they build again, so I believe what we do is we build and run the tests against a particular commit
Uh-huh.
in the regular CI, and we say, okay, everything's good. Then we run the release job, which will just create the binaries from that tag.
Okay. I see.
But we somehow, we need a job. We need a way in the job to say, okay, this time run it with everything. so that it would do it twice. Now that would potentially take twice as long. And then when they did the release, they'd also want to flip on the and okay, let's make it.
Yeah, right. I mean, yeah, like definitely the build time is doubled. Plus like it like time for the training scenarios to execute. Sure. But again, like that depends. Like if we are, like if we see that there are improvements, for example, like if we just train with Acme and see if there are significant improvement in micro benchmark, then it might be a worth giving a try, right?
Yeah, I'm just trying to think how to. Like, I think first, yeah, we'd have to see, is there, I mean, I don't know if there's any way to really mitigate that doubling of the time other than,
Yes.
like, it's too bad you couldn't do the training once and then reuse that training data, even if it wasn't quite as good, right?
Yeah.
But it doesn't sound like you can do that, right?
Right, because yeah, it basically uses the some of the files that were produced in phase one.
Right. And those files change every time.
And those files, yeah, because your code has changed, so it has to rebuild.
Yeah, I guess it certainly seems interesting. I've got first of all, I'd be quite interested in seeing the data that you've collected for Acme Air.
Mm-hmm.
The other thing is that, I mean, if I was taking Node, I think your data that you've shown suggests that if you train
Mm-hmm.
Node on one particular set, we then seem to see an improvement in the performance of that benchmark. So, for example, if you train it purely on Acme Air, we see an improvement on Acme Air.
Yeah.
If I was running Node in production,
Mm-hmm.
I would want it trained on my production software that I was running. So I
Yes.
wonder if there's a way of us being able to put something together to make it easy for someone to download a performance enhanced version, for example, which gives them the tools to be able to create their own optimized version specific for their production code.
Yes. Yeah. I mean, like that's one possibility where you don't train for like Acme or something, but user can use right tools provided by Node community to build a like optimized binary for their scenario. Yes.
But what are the external dependencies?
Well, like there are no external dependencies. There is like all you need is like for example for Windows it needs like Visual Studio tools.
But are
And
those what you need to do the regular build?
what's that? Yes.
Yeah, like I'm wondering, like thinking along what Gareth is mentioning there. Like the first step might be to try and integrate into the make file a target which would basically build. I guess the thing is, it would have to build, run the tests, run the training things, and then rerun, right? Like I'm just wondering if there was like a target, if there were targets that were in the make file that basically said make the training, make the. So first of all, you have to do a make, and you have to specify basically like get ready for PGO or something, right?
Yes. Yeah,
Then,
basically, yeah, like phase one itself, you need to change like one link time flag basically in form of GIF. Like there is a flag.
right.
So yeah.
So you do that, then you build Node. Okay.
Yes.
So now you've built Node, then you run your benchmarks.
We run the benchmark and then we again change the flag saying that okay, now I have run the benchmarks. Now it is time to generate the optimized binary. So that flag actually tells to use the profile data files to produce the binary.
Now
So there
those profile data files, where do they get generated?
they get generated in like the same place where node.exe is exist.
Okay, so those could be copied though, right?
Yes.
I'm,
Those
I'm just thinking, like, if we had a tag that says, make PGO enabled,
Mhm.
then you would need to say, okay, now you can run your things. Then we would want to say like make dist with PGO packaging or something, right?
Yes.
So those two extra targets might be useful. And then I guess we could see that you could have. I don't think it needs to happen actually at the same time. We could separately have a job that goes, so a new release gets published, right? And it's a particular hash. You could then envision a job that would go in the background and say, oh, there's a new release. I'm going to build in this PGO enabled mode. I'm then going to run this set of benchmarks, and then I'm going to do the make dist in this particular configuration.
Yes.
Now the wrinkles to that is, we do have our release machines separated out. So I don't think we'd want to be running like all the benchmarks and all that kind of stuff on those machines.
Right.
There just aren't as many of them there, and all that.
Right.
So, it might be something like we would run them on the regular farm, and then we would copy the files over.
Yes.
I guess the problem with that is if those machines may not have the same OSs even as the other ones. I guess that probably matters too, right?
That might. I mean, as long as it can build like Windows, for example, node.exe for Windows, that should be fine.
So, but for example, like, in Linux, we may test across Fedora, other bunch of things, but we build on CentOS. Now, I think maybe we do at least have some test machines that are at the earlier levels as well. Okay. I just know our release machines are at the earliest levels so that we actually get, support across the different versions.
Yeah, I mean, like definitely the build tools have to be compatible, I guess. Like, for example, if you generate profile data files with Visual Studio 2015, I don't think you will be able to build optimized binary using 2006 or 2013.
Right.
So, but definitely like moving the files is possible, and that's how I did like I have created the instrumented binary, and then I just copy it, like run the training scenario, produce the data file, and that's it.
Right.
Like, I don't have to build the instrumented binary again and again.
So okay. So I mean, there'd be a bunch of wrinkles in trying to get that process in place. I just can't see us integrating into our regression tests and even into our standard releases. That's going to be harder, but there might be like an alternate flow where there's a second set of binaries, which would be, okay, here are the PGO enabled binaries. There'd be a bunch of work related to that, but I think the first step of actually making it easy with make targets to be able to do the steps isn't a bad thing, because then if somebody wants to try it out, they can do that. And like Gareth said, if you want to build Node yourself and optimize it for your app, that's not a bad thing. And then, once that's there, you can, if we have enough people willing to actively work on it, we could work through the steps of saying, okay, how would we do an offline sort of flow to generate some builds that people at least could try out with to start with? Like, here's the optimized binary versus the unoptimized, right?
Right. And I mean, like I'm experimenting with like some other like partners within Microsoft that are using like Node, and recently like I have shared them the binaries like optimized versus no optimized, and I just screened for their app.
Yep.
And I haven't heard back from them yet, but it's just like yesterday. So
okay. And I think a few of those other, like the experiments of, can we see it where it's actually made things worse, which I bet it can. It's like, how likely is the question.
Even I don't think it will make it regress, but the ECMAIR exercise will be good to verify that. So I will definitely try out like training with ECMAIR and then see its implication on core benchmark.
Yeah. So definitely, it sounds interesting. I think the challenge I see is the amount of work to get something that you'd be able to give out to the community easily,
right?
Versus I guess it's like a 5 to 10% performance benefit. It sounds like.
Yes. I mean, so for example, this is the like most exhaustive training set, for example.
Yeah.
And there I saw like minimum like 5% win in ECMAIR.
Right. Okay.
And then in core benchmark there was a hell lot of improvements. So
Yeah, so those micro benchmarks, but I guess they're fairly specific, right? Like,
Yeah,
so I don't know how representative that would be in real life.
true. That's true. Yep.
So yeah,
But yeah, but I mean, I think there's probably still quite a bit to learn, especially even if we're only looking at the sort of optimizations that are being applied. There could be areas of Node that are sort of pointed out as this is an area that isn't normally optimized very well, but perhaps there could be sort of code changes made to also sort of implement or exploit these sort of optimizations in a normal binary if there is something that we notice that
yeah,
is consistently improved by running the PGO.
that's true too. It's an interesting, like you're basically saying it's a way of pointing out where you could get better by making the code better.
Yeah. I mean, that's the thing. Like, I'm not sure if you can visualize what things it moved around. For example, what functions it inlined based on the training scenario. Like it,
Right.
like while building, it does call out like, okay, it has optimized X number of functions for speed, but it doesn't call out like what exact functions. So yeah, I can dig through and see like if we can get that information out, and then we can just like hand code and like optimize those functions.
Yeah, because that'd be cool. You know, if it could even, yeah, that's an interesting one where it gives us the pointers of where to optimize to. It's kind of quite interesting.
Okay. Yeah, I can follow up on that.
But it seems to me like the first, you know, concrete thing too is I don't see any reason why having a make option to build in that mode wouldn't be a good thing.
Mm-hmm.
You know, that way, like Gareth was saying, if somebody wants to build it themselves and they can turn on a few options to be able to do that, that sounds good.
Right. Yeah.
And we would want those, you know, if we were gonna use it in the regular binary production, we would want those anyway, right?
Correct. Sure. Yeah. Yeah.
Okay. So it sounds like there's some decent next steps.
Mm-hmm.
Any other things we should talk about, do you think, or discuss? Like,
Yeah. I mean, yeah, that's what like this was like just a first step to see like what you people think about it based on the results that I've seen. And yeah, definitely like it's a like from what I hear, it's a good thing to try out next steps. And the only pain point I guess is to finding the right training set and the build time. This
yeah, it's sort of the training set to convince yourself that it's
right.
going to give you the right answer, and then the logistics of actually building something.
Right.
I mean, I think if we got we're completely convinced that it's always going to give us like a 10% win.
Mm-hmm.
Then you could get to the thing that say, okay, well, you know, how much effort are we going to have to go through in terms of actually getting binaries that will give us that?
Correct.
I mean, I think like the one I just walked through where it's basically an offline process. You know, we deliver binaries, but then behind the scenes, you generate a second set of binaries so people can choose from the regular ones, which are always available first,
Right.
or the optimized ones, which may, you know, take a little longer to get generated.
Mm-hmm.
That might be a way to sort of factor out the time lag, you know, the extra effort, because you'd only be doing it once for each release.
Right. Sure.
And that's assuming all the tests still passed and everything, but
Mm-hmm.
hopefully that would normally be the case.
Yes. And yeah, I mean, yeah, and for like again coming back to the training scenario, like today, like the way the node performance is like I think determined is obviously by the micro benchmark and like ACME, and if like other Intel benchmark shows up, uh,
Yeah,
that
we have those, you know, we have the about 9 that we run and track nightly, but
right,
you know, those are the ones, and we hope to add in others like
right,
the new Intel benchmark and stuff to get as broad a coverage as we can.
right, because that's like I think yeah, like I went through that benchmark and it is like more realistic because it creates like a lot of objects versus ACME, which is like it doesn't create much objects, so that's like definitely a realistic one. But like if we can see improvements with PGO on this benchmarks and also micro benchmark, I think then it's like worth pursuing this, I guess.
Yeah, I think so. Yeah, I think long term it sounds like a good, 10% is enough benefit that it's worthwhile. It's just the work to get there is the.
Right, right.
And I
Yeah,
think so. Yeah, we need to build out our benchmarks, and then but if you have time just to invest in it, it seems worthwhile.
okay, okay. So
And
yeah,
I like the idea of definitely making a make target, so that, that's a concrete thing that can help people if they want to try it out and stuff. So.
right. Okay, yeah. So I think like a couple of things that I should be looking into is like seeing the implication of like one training scenario on like core benchmarks,
Yeah.
and then seeing if the PGO can spit out the optimization that it did, so we can hand code that.
Yeah, I think that's also interesting. So.
Yeah. So yeah, I think is there anything else that you want to look into?
I think those are the good next steps, and then once we've learned what we can learn from those, we can think of
Okay.
whatever the next thing is.
Okay. So yeah, maybe once I have some data, then maybe I can like update this issue, or like I can email you, and then we can schedule next meeting.
Yeah, I mean, I think I would say update the issue and come to the next regular benchmarking meeting, and we can just sort of get a.
Okay,
You
round
want
it.
to come regularly and give the rest of the people an update on where you're at. That would probably be good.
Yeah, that sounds good. Okay.
Okay, sounds good. So I'm just gonna see. There's shows as 2 viewers. So what I'm gonna do is I'm gonna look on node dev. So let me just. And so if you go to node dev and ask a question, I'll just check to see if there are any there. It'll just take me a second to log in. So yeah, just give me 1 minute. I'm logging into IRC. I'll look on node dev just to see. I don't see any questions there yet, but we'll give people just a minute or two in case there are.
What is that link? Sorry.
It's the IRC channel, the node dev IRC channel.
Oh, okay.
I just thought that that's one way people can ask us questions. I'm just trying to think, is there any other? I don't know if through YouTube there's a way for people to ask questions. I'm looking at the let's see, open. There is a YouTube live chat which I've opened, so I don't know if people can access that directly from the outside. That's another way that you could ask a question.
Okay. Can you share the link for the node dev?
I'm not sure it's just a link. It's basically you have to join node dev.
Okay.
On IRC. Here's the link for the YouTube chat.
Okay.
So if you go to if you need an IRC client,
yeah,
post it on Freenode, and then you can. It's like hashtag node-dev.
Okay.
But I don't think I see any questions. So I think at this point we'll call it a day. And if anybody has questions, they can obviously raise an issue on the repo, and we'll get this issue at comments in this issue, or show up at the next benchmarking meeting to ask questions.
Right.
Okay.
Okay. Thank you.
Thanks. Talking to you all.
Yeah.
Bye.
Bye.